Moving on in our booklet, we are on page 53. And keep in mind you can scan this into your cell phone and actually get a short video produced by Math Zone to review the kinds of things. What we're doing here is going over in more detail these particular answers and a little bit of the theory behind them. So as we look, what you might do physically or mentally is factor this into, in a sense, some ones. And as we see here, 9 times 4 is 36, and then 63 is 9 times 7. So the 9s would cancel out. That would be a 1. And what I did with the k to the 9th, I factored it into k to the 7th times k to the 2nd. And I did that because my bottom was k to the 7th. So now these are 1s. And we get the answer 4 k to the 2nd over 7. Now we'll do the same thing with these. You can pause as we go on before I show you how to do it, and then I'll go over it with you. So again, the strategy is to factor this and see what common factors you have. Here there's a common 5 factor, which is a 1. And there is a k to the 7th there and a k to the 7th there. So we're left here now within our numerator. We don't write the 1, just k over 8. Now in example 3 we have binomials, so we're looking for common factors within these binomials. Give you a chance. Now as we look at this one, we see we could take an 8 out of each term, but then I saw I could take a 4 out of each term down here. So I wrote the 8 as a 4 times 2. So that when we go to factor this, taking out common factors, we see we can take a 4 out. And now these are also common factors. So we're left here with only 2 as an answer. That's 2 over 1. We don't write the 1. In number 4, as we look at it, I could write it out again, but the only common factors we have is this. So our answer then is 12 over x plus 9. And you might say, well, couldn't you factor a 3 out of these two? And the answer is no, because 12 is not a factor and 9 is not a factor here. You can only cancel out common factors, not a term and then possibly a factor. Only factors. All right, now for this one, as we look at it, again, you can factor out at least 6x here. And let's see what you get. So in example 5, perhaps something like this, factoring a 6x out of each term. And then here I'm separating 48 into 6 times 8. And then I have to also put x to the 2nd here. Now I factored the x to the 3rd into these two factors. So now these are all factors. So here the x cancels, the 6 cancels with the 6. The x cancels with the x. And we're left with 6x minus 6 over x squared. And we shouldn't forget the 8 there as well. Going on to page 54 now. Let's look at the strategy involved here. So looking at the rule, we said that when we have the bases are the same and we're dividing, we just subtract usually the smaller number from the larger number, and that's indicated here. So the 7, again, I tell my students when it crosses that division bar, the sign of the 7 changes. So we get 4 to the first, which is, of course, just 4. Now, in simplifying this, you're going to raise this base 6 times. That is, multiply it by itself 6 times. So there's a 1 there as the exponent, and there's a 1 there that we don't write. So when we're raising a base to a power, it would be n, let's say a here, to the m, raising it to the nth power. We're going to multiply these exponents, and it becomes a to the mn. Notice the difference. And here it'll be 5 to the 6th power. Now, students often make a mistake here. They'll just say, well, 6 times 5 is 30. No. Again, you're multiplying the 1 that's not written by the 6, the exponent. And again, the same for the denominator. Z to the 1st power times 6 would be z to the 6th. And since they're asking us to simplify, they want us to put this in our calculator. 5 caret 6 is this. Now, in example 3, if we tease it apart a little bit, it looks like this. Now we're going to raise 3 to the 2nd power. Remember, there's a 1 there. That's 3 to the 2nd power. This will be 9. X to the 2nd. There's a 1 there. Now when we raise x to the 1/2 power to the 2nd power, we just multiply, and this gets 2 over 2, which is 1, so this is over x. So we now have a common base here with factors, the n2, 9. So take the 1 up, subtract it from the 2, 9x. Now here, this is pretty simple. We have the 5 over 3. We're going to subtract the 3 from the 5 and get x to the 2nd. And I think there's room to see this one here as well, but let's write it bigger. And the normal way to do these, of course, is you just take 15 goes into there once, 15 goes into there 4 times, but we can do it this way too. 15 will cancel with 15, and you're left with a 4. And then a to the 4th is a to the 3rd times a to the 1st. And then on the bottom we have a to the 3rd, so this is a 1. This just cancels out. And then b to the 12th is b to the 6th times b to the 6th. Or just bring the 6 up, subtract it from the 12, and you're left with b to the 6th. So now we summarize. We're going to have a b to the 6 on top over just a 4 remaining in the bottom. And you can check your answers on page 67. Okay, going on. We want to simplify the following expressions. And this looks like another page of very similar material. So we'll give you a chance to work on it, of course, and then we'll show you the procedure that I get. In example 1, we see the number part, the coefficients. There's no common factor. But with the x's, again, we can bring this 5 up, becomes a -5, subtract it from the 12. But another way to look at it is x to the 5th times x to the 7th, and then x to the 5th will cancel with an x to the 5th, and we get 9 x to the 7th over 14. All right, in example 2, I think we can factor out a 2 from the top there, and we get 2y minus 2. And then over here we can factor out a 7 from each term, and we get y minus 2. And now we see that we have a common factor of y minus 2, so our answer is just 2/7. In example 3, again, you're looking for a common factor. 9 times 5 is 45, 9 times 6 is 54, so the 9's would cancel out. Now notice in the numerator we have x to the 16th. In the denominator we could factor that into x to the 16th times x to the 4th, so the x to the 16th would cancel out, and now we're left with a 5 in the numerator and then a 6 x to the 4th in our denominator. And it is okay to have a variable in the denominator. Remember, another way to write this would have been 5 over 6. Bring this up and it would be x to the negative 4. Moving our variable and exponent into the numerator across the division bar changes its sign. But generally they want exponents to be positive, so this is what you would write. In example 4, they want us to multiply and simplify. So theoretically we could kind of collect like terms on top. We get 12 x to the 11th over, I could put it 10. Now x to the 0 is just a 1, so this is just going to be x to the 2nd. Now we can factor out a 2 there, so we can go 2 times 6 over 2 times 5. And then as we bring our 2 up to our denominator, subtract it, that's going to give us x to the 9th there. And the 2's just cancel off. And so our answer is 6x to the 9th over 5. And we're going to do the same here. There are different ways to organize this, but I chose this. 42 is 6 times 7, 12 is 6 times 2. And I did that way because there's a 6 and a 7 in our denominator. So now this 7 will cross out with this 7, cancel out. This 6 will cancel with this 6. And that's about the size of it, actually. Now we have left for a number here, 12. And now we have c to the 7th here. We'll cancel out, subtract 7 from 9 gives you c to the 2nd. So 7 subtract from 9 gives you 2. So this is done here. And then we have a 2 up here that we will subtract from the 5 and in a sense get a 3. So that's going to be over d to the 3rd power. And it never hurts to check your work. And I see my answer is different from what they have listed in the answer key, but I believe this is correct.